Hi, so in this example, we're going to find the area under the normal curve for a certain given z-score. And in this case, we can see we're looking for the area to the right of the z-score. So there's a couple of ways that we can do this. The first way is we can use the table of values. But recall that the table of values only give area from the mean. So if we take a look at the table, we can see that the area from the mean is the yellow shaded. And so in our case, we aren't looking for the area from the mean. We're looking at the area to the right of the z-score. So let me go ahead and draw a line at the mean. And then you can see that there's a little bit of space here. Do it in pink right here. And that little piece there, that's the area from the mean. So that means the table value is this little pink area. But we are given that this area here it starts at a z-score of 0.16. But we do know something about the upper half of the normal curve, right? So let me go ahead and draw it down here. I think it might be better. And then we can see that here's the mean where it's 0. And then we do know like this upper half is a area of a half, right? Or 50%. And the upper half of the normal curve also has an area. I mean, the lower half has the area of a half or 50% because the whole area under the curve is 1, right? Well, if we have this z-score that's sitting pretty close to the mean, right, 0.16, and I need this area, the idea is that we can take the bigger area, right, and then subtract this smaller area, and then we can get this area from the mean. So it's a little bit of a geometry. We just take the bigger area and then subtract the smaller area, and then we can get this little area from the mean. So that's going to be our first way of doing it. And then once we get that area from the table value, we can go ahead and subtract it from a half. So let me write this down. Okay, so the first thing is that we get a table of values. So even if we look up the z-score of 0.16 on the table, it'll give us the table value, right, which is the area from the mean. So the third piece is right when we look up the z-score and get the table value, this area or probability that's greater than 0.16, that shaded blue area, is going to be a half, which is this bigger area, and I'm going to subtract this smaller area, and then I'll get this blue. So minus the table value, and that will give us essentially the blue area. Because again, we don't want 50% of it. We want 50% minus this little piece here. And we can grab this little piece here just from the table. Okay, so I think we're ready. And so let's go ahead and start. Okay, so the first step is go ahead and look up z equal 0.16 on the table. And that way we get the table value. So let's go ahead and go over to it. And we have 0.16. So the z-scores in the column is the ones place and tenths place, and the z-scores on the top row is the hundredths place. So 0.1, so right here is the second row, and then 6. So we get 0.0636. So 0.0636. So this is this little area, right? 0.0636. So in the next step, step 2, we can go ahead and find that probability of a z-score being greater than 0.16. And that's going to be 1/2 minus the table value, which is 1/2 minus 0.0636. Now we may not know that off the top of our head, so we can just go to our calculator and go ahead and put in 0.5 minus 0.0636, and we get 0.4364. 0.4364. So that's the answer rounded to 4 decimal places. But there is another way to do it in the calculator. And then to go to the calculator, you would just hit second vars, which gives you the distribution menu, and do normal CDF. So let's go ahead and take a look how to do that. So here we can go ahead and have second vars, which gives you the distribution list, and go to normal CDF, which is number 2. And you're just going to do a lower bound and upper bound, meaning left endpoint, right endpoint. So we know that it starts at 0.16, but then it goes all the way to the right. And we can't put infinity in here because there's no infinity symbol. So we're just going to put the largest number your calculator has, and that's going to be 1e, and that's this E here that you see above the comma. So hit blue with blue, second comma gives you the E, right? And then 99. So the largest number that we can put in the calculator is 1e, which is that second comma, and 99. Keep the mean and standard deviation at 0 and 1, and go ahead and hit paste, and then enter one more time. And notice we get the same exact result as we did from the table, 0.4364. So you can use essentially the table of values and subtract from 1/2, or you can use the calculator. It's really up to you and the student and what you prefer. However, either way will work.